So let's just do one more. And we again have a cubic expression with a known factor of x minus 5. So let's just move over here. We know that, let me change colors, p of x is this x minus 5 multiplied by some quadratic expression. We'll call it q of x. And so to find this q of x so that we can then further factor it, we'll just divide our polynomial by x minus 5 since it's a known factor, so it will divide evenly into this. And let's carry that out. So we'll do x minus 5. That goes on the outside of our long division. And we'll do x cubed. Notice it doesn't have a square term, so we have to put plus 0, x squared. Then we have minus 21x minus 20. And we'll do the long division. So x multiplied by x squared will give us x cubed. We multiply by the linear expression out front to find the remainder. So we get x to the third minus 5x squared. And now we subtract. We need to find that remainder. And the first terms cancel out like we want. And we have 0x squared minus negative 5x squared. So we're really adding 5x squared. And when you add 0 to that, you just get 5x squared. We bring down the next number, the minus 21x, and we repeat the process. If we multiply x by 5x, then we'll get 5x squared. Now we multiply to find the remainder, and 5x times minus 5 would be negative 25x. And we subtract, find that remainder. First terms cancel out. We get minus 21x plus 25x, so that would just be 4x. And we bring down the minus 20 to find that remainder. Let me just make a little bit more room. And we repeat one last time. So we have that x times 4 would give us 4x, so this would be plus 4. So you get, when we multiply 4x, and then minus 5 and 4 would be negative 20. We are subtracting something from itself, so we get a remainder of 0. 4x minus 4x is 0, minus 20 minus negative 20, or plus 20, also 0. Since our remainder is 0, you can feel fairly confident that this is correct. And so we now just need to further factor this x squared plus 5x plus 4. So our p of x right now is that first known factor, x minus 5, and then multiplied by this quadratic, this x squared plus 5x and plus 4 here. So we just need to factor this quadratic. So let's just rewrite it. We have x minus 5 times by 2 binomials multiplied together. And these two linear factors will give us our quadratic here. So what we need to do is figure out these two missing terms in each of them. And since the coefficient on x squared is 1, we can use the faster method of factoring this. We don't have to use grouping. So the first term will be x in each of these. And at this point, we just need to figure out these two number terms. But we know that they multiply to 4 and add to 5. So let's write out the factor pairs of 4. Could be 1 and 4 or 2 and 2. And you can see that 1 and 4 are the only ones out of these two that add up to 5. So this will be plus 1 and this will be plus 4. And of course you can check this by multiplying it back out. Since x times x is x squared, then you get 4x, then you get 1x, and we get 4 at the end. The 1x and the 4x will combine to 5x. So it's helpful to check your work along the way in these just so you know you're not making any mistakes, because there is a lot of work involved and it's easy to make a mistake when you're doing polynomial long division. But what we found is that our polynomial has these three linear factors of x minus 5, that was our known one, and the other two we found were x plus 1 and x plus 4. Now you might be wondering, what is the advantage of all of this? Well, if we were going to look at the graph of this polynomial, let's just draw in some quick coordinate axes. Knowing these linear factors can help us figure out very quickly when the polynomial is equal to 0, or which x values would set this polynomial equal to 0. And these are called the zeros of the polynomial, or the roots. And we can use our zero product property. You can see that when x is 5 or -1 or -4, that the entire polynomial would be 0, since, for instance, if we put in 5, 5 minus 5 is 0, and 0 times 6 times 9 is still 0. 0 times anything is 0. So we'd be able to graph at least these points on our polynomial. So we can plot these at 5, so right here, at -1, and at -4. So we know our zeros. And then when you learn about the end behavior of polynomials, so this polynomial is going to behave like a cubic, and the end behavior for this is going to look just like a normal cubic function. So if you know what y equals x cubed looks like, which very roughly is going to look something like that, then you know roughly what this polynomial will look like as x gets really big or really negative. So it's got to come from below, since that's based on the end behavior. It's going to go up, come back down through this 0, and then go back up through this one. Now, we don't have enough information to determine, for instance, how high this is or how high that is. There are techniques to do that, though. In fact, if you know calculus, you can find these points very quickly. But this whole process, in essence, is just very useful when it comes time to actually graph these polynomials.